Thanks to Matplotlib, in my case, in this talk at least, we will talk about Matplotlib. Matplotlib so far is not the only Pythonic way to do data visualization, and we are gonna see some examples on this at the end of the talk. According to the website of the homepage on Matplotlib, Matplotlib is defined as a Pythonic library for 2D plotting. Let me read this. It's a Python 2D plotting library which produces publication quality figures in a variety of hard copy formats and interactive environments across platforms. Matplotlib can be used in Python scripts, the Python and iPython shell, as well as MATLAB and or Mathematical, web application servers, and 6 graphical user interface toolkits. So, the slides, this slide isn't helping me so much, but the idea is to identify the, sorry guys, the main features in this, the most important part in this definition is that it is, according to the website, it is a 2D plotting library. Indeed, we're going to see that we can make also 3D plottings with Matplotlib. Then it allows to produce figures in different formats and could be integrated into interactive environments. Matplotlib can be used in Python shell or in scripts, of course, Python or iPython shell, and web application. This is very interesting. And other graphical user interface, for instance, Qt, JTK, stuff like that. Data visualization techniques are distinguished in 2 different categories, namely static and dynamic techniques. The static visualizations can offer only precomputed views on data. So they are not supposed to be interactive with the user. This means that usually static data visualization plots are presented in multiple formats to have different views on the same data. On the other hand, dynamic interactive visualization, dynamic is a synonym for interactive, visualization tools allow the users to customize the way they want to view the plotted data. So what about us? Matplotlib seems to be, in general, according to the definition, seems to be a static data visualization toolkit. As far as we know, these are the functionalities offered by Matplotlib. On the other hand, a very well-known dynamic toolkit, dynamic library for dynamic data visualization is D3, which is implemented in JavaScript. And in this talk, we're going to ask, we wonder if there is a sort of boundary or a sort of bridge connection link between these two different words. So yeah, I mean static and dynamic visualization. What about Matplotlib? Matplotlib is very Pythonic, has a nice API. I wrote before nice and intuitive, but I removed intuitive because sometimes it may not be so intuitive. Anyway, I think that it has a nice API that is very Pythonic because it provides the same functions, the same features if you want to use them in an object-oriented way instead of functional way. I mean, calling functions instead of configuring objects and methods. It's full-featured because it has a very, very huge set of functionality. And in general, it is largely used in the scientific community, for scientific stuff, but mainly because it has a great integration with NumPy and SciPy, but anyway, is not for science only anyway. Matplotlib at glance. Matplotlib can offer the possibility to plot very, very different. This is just a very small subset of charts that you can produce with Matplotlib. You can make plots, box plots, histograms, bar charts, pie charts, 3D surfaces charts, and these are string charts. Okay, so this is a very, very restricted subset of the entire set of charts you can produce with Matplotlib. So how can handle with all these charts? So the idea now is to take a look very briefly at how difficult in general, or what is the effort to produce charts with Matplotlib, and try to wondering in which case you should use one chart instead of the other. Okay, very, very first and simple example is to plotting a curve. Plotting a curve is really, really straightforward. We're gonna implement this few lines of Python, and in this case, this is pure Python. You can notice that there is no import of NumPy. So we create, in this case, this is the scene function, and we plot the values of the scene function for every value of x, which goes to values of x are distributed in a range of 100 elements, starting from 0 to 2 times pi. Okay, and this is the plot. In two lines of Python code, we may create the plot and then show it. Okay, and this is pure Python. No NumPy required. Anyway, if you want to use NumPy, this is, in my opinion, this is even easier because NumPy is in charge to create the x values with linspace, which is a single function call. Linspace generates a equally distributed set of data, in this case 100 values in this range, which is exactly the same. So no list comprehension are needed. No list comprehension is needed in this case. And we of course obtain the same results. In the API of Matplotlib, this is completely transparent, in the sense that you may pass x as a NumPy array or as a Python list. This is completely the same. Okay? Very simple example. Go ahead. We want to plot in the same chart multiple curves. How we can do this? Really simple. We have two different values for the y. So in the blue case is the scene function. The green case is the cosine function. We generate two plots, one after the other, and then we show it. Okay? In this example, you may see that one of the main features of plotting of Matplotlib is the so-called deferred rendering. This means that you may create how many plots you want, but these plots will not be shown until you call the show function. This means that in Matplotlib, you may customize your plots. In the following slides, we will see how we can customize our charts with changing colors, adding annotations, and whatever. And after that, you can call show to view the resulting chart. Okay? This is called deferred rendering. Go ahead. In this case, we do not want to produce multiple plots in the same plots, but we want to create subplotting curves. So in the same single plot, we want to show two different curves. In this case, we have just some lines more of Python to write, but they're very simple. Matplotlib offers this function, which is called subplot to grid, that allows you to arrange the different plots in a grid. In this case, we create a grid of 2 rows and 2 columns. The first plot here spans 1 row and 2 columns, and the same for the second one. In the upper part of the grid, there is the cosine function, and the sin function is on the left, is on the lower part. With the C parameter, we can change the color of the plot. In this case, G stands for green, this is, and B stands for blue. Okay? So if we want to change the color of our plots, we have to specify it in the C parameter. And this applies to this type of feature is exactly the same for every kind of chart in Matplotlib, not only plot, that is X and Y values. Okay? Again, we can change also the aspect ratio of the figure. So we may handle different resolutions, different ratio. And in this case, we also handle with not only with the color, but with the line width. So we specify that the y1 is sin function, y2 is the cosine function, y1 has a line width of 2, the line width of the cosine function instead is 3. So you may see that the blue one is the sin function, so this is the sin function, and this is the cosine function. They have two different, maybe it's not so clear, but they have two different line width. Okay? It's a simple parameter in the function call. Okay. Another very useful feature is to plot the grid. Sometimes we may have the need to plot the grid inside a plot to make further analysis, for instance. So we may add the grid to the plot by adding a grid. You see the further rendering working now? We have created the two plots, and then we add the grid, and then we show it. Okay? So we may add all the features, all the customization we want before the show function is called. And we got it. Okay. In this case, the grid has a line width of 1.5, and it is drawn with dashed lines. The color is 0.75 black, which means sort of clear gray. Okay. Then, moreover, we may also add not only the grid to a plot, but also additional annotations. For instance, we want to add some important marker points on a single plot, or also some annotations, for instance, an arrow pointing on a single point. This is very, very straightforward to do it. And we may do it directly from, at least for the markers, directly from the call of the plot function. This is all embedded in that call, that function call. We said that the marker size is 9, so the marker size controls the size of the markers. These are markers. We may change the edge width marker, the color of the marker. K stands for black. In particular, the edge color, so the edge color is black. Marker O specify the shape of the marker. O means a cycle. There are different kind of markers, and the documentation about this. Matplotlib has a very good documentation. A lot of examples, a lot of nice stuff showing you how it works. Okay. And then we have the annotation. So we annotate the plot with scene point is, this plot is cut, sorry for that. And we add to the annotation an arrow, so that is black and shrink 0.05. Okay? And this is only for the plot of the scene function. The cosine function, the green one, is exactly the same. Last, but by no means least, we can change the scale of the plot. Okay? So in this case, we may plot the y values are in a log scale. And in the same plot, we may show the legend and use different annotation that is automatically generated. We simply call legend. In this case also, we use as labels for the legend LaTeX annotation, which is very useful in the scientific stuff. Maybe less useful in other contexts, but in scientific stuff it's very useful. Okay? So in this case, this is f of x, this is e to the x, and this is log x. What about the other charts? We've seen so far only plots, which is very simple, very straightforward. We may create, for instance, scatter plot. We may need to create scatter plots when we have no necessity to view the values of when the values of x does not, we are not interested in see the function, the relations between x and y. But we implicitly assume that one point follows another one. For instance, when our data is a time series. Okay. Scatterplot is really simple to produce. In this case, we generate random data, so random scatterplot. We call scatter. The values on the 0 column is for x, the 1 column is for y, and we got it. We may change the colors of the scatter plot, and we may use color maps, which is a very interesting feature. CMap is the parameter that the function scatter accept. The cm.hcv is the one of the different color maps offered by Matplotlib. In an example that we will see shortly, we will see that there are different kind of color maps. In this case, we may change, we may use the color maps in combination with the angle, which is an array of values, and the colors of the different plots depends on the values of C, so on the values on the angle. This is the rationale behind this. Okay, I told you before that we may also create 3D scatter plots. 3D plots. We will see 3D scatter plots. So we may view scatter plots in a 2D representation or in a 3D representation. This is the code to do this. We have to use the Mplot3D library, which is built in Matplotlib, provided out of the box. And we create the, we set the X, Y, and Z labels. We create a figure, has a plot there, and then we call scatter. The function we call is exactly the same. We had only an additional axis, the Z axis. But the function we call is exactly the same. To create a 2D plot, scatter plot in this case, or a 3D scatter plot. We may create also, for instance, 3D bar charts. The function is bar. That is exactly, the code here is exactly the same. The only change is here is the bar function instead of the scatter, and the fact that we added a color to the first element of the bar. In fact, if you can see this, the first bar in this different bar charts is colored cyan. Okay? We may create, and as I said before, the function to create 3D plots is the same to create 2D plots. To create 2D bar charts, we still use the bar function, but in this case, we consider only a couple of values instead of triples. And the fun stuff is that Matplotlib also support the XKCD visualization. So if we want to create XKCD lookalike charts, we may do this in a very, very Pythonic manner. In particular, this snippet of code is extracted from this XKCD comic. Really, really funny. What we missed behind. We didn't talk about histograms. Histograms are not bar charts. They're a sort of bar charts, special cases for bar charts for probability distributions. I told this because sometimes there is some confusion about the difference between histograms and bar charts. Horizontal bar charts, and the function to call is quite similar, bar h. Same parameters, same stuff. Bar h represents the same data in horizontal bars instead of vertical ones. Pie charts are also allowed, for instance. This is just to mention the most famous ones. Box plots, path plots, stream plots, whatever. Okay? You may go on the Matplotlib side, matplotlib.org/gallery.html, to see a very, very large collection of examples. Hey, wait a minute. What we missed? Where's the fun stuff? There's in Matplotlib, you may also create animations. That's really cool. Animations, the creation of animations encompasses very few steps. 4 steps. Very simple. We create the figure. We call the init. We create, the init function, which is the function that is responsible to initialize the animation. The animate function is the function that keeps on generating data, the one that will be shown during the animation. And finally, we create animation.functionAnimation that takes an input, the fig. So the figure we created here, the animate function, which is the function that keeps on generating data, and the init function, which is init in this case. The number of frames, the interval, the bleed through is a parameter to the rendering. And this is the result. The scene function animated. Cool, yeah? Another more tricky example is the, or the final part, okay? This is a more tricky example. I didn't report the code because it's too large, but very, very funny. And this is a sort of static data visualization. Okay? This is not interactive, but it's animated. Okay, so the last part, now for something completely different, as MultiPython said. And for this part, we're going to use iPython notebook and some demo online. So pray for me that everything works. Okay. Well, okay. So, first of all the examples gathered in this notebook are taken from the notebook of Jake van der Plas, which is available online. So it's not completely my own stuff. Try to toggle the toolbar, toggle the other. Okay. Okay, first of all, try to see how Matplotlib can be interactive. The first example we're going to see is thanks to the iPython widget. Do you know the iPython notebook or how it works? There's somebody that doesn't know how it works. Okay, I may go ahead. Okay. iPython notebook in 2 words, in simple words. The notebook is an iPython shell that runs in a browser. Okay, so we may apply the same stuff here in a Python shell, but this is really simple to show. Okay, so we imported NumPy and Matplotlib, and moreover we have this directive which tells the iPython notebook to show the plots inline. So we're going to see the stuff as we created. Okay, so let's try to draw a scatter plot exactly as before. In this case we used some color and we added a color bar on the right, sorry. Okay, now let's try to make it interactive, and we're going to use the interact widget of the iPython library. Okay, we wrap the call to draw scatter to the interact. We set that the interact widget should have size widget, size parameter, alpha values, and schema. So the different color maps we want to use. For instance, we want to try to change the color map. Yes, we do. We click, and we've done. We may change. Okay, this should be clear. Okay, directly in the browser. So very, very interactive. May change the alpha code, which is the opacity. So it should be okay. Just we may change the size of the markers. And got it. Okay. In this case, every interaction to the browser means a call to the iPython backend server that get the options, render the options, and got back the data to the client. A very completely different stuff is, okay, due to lack of time, I can show you this other example. This is very interesting. It's about random graphs. So we may generate with network X random graphs. We may change the algorithm to generate graph and play with nodes. Okay, I need to run up. The last thing to say is MPL D3, which is a very interesting project. This is from Jake Bunderplas. And this library aims to integrate the D3 JavaScript library to Matplotlib. Let's see it in action. Okay, this is the scatter plot, but now this is annoyingly static. Let's change to interactive version. Okay, in this case, we have a new widget that allows me to move in the figure, zoom it, using the D3 visualization. Okay? Can you give me a few minutes? A couple. Thank you. This is very interesting. This is worth mentioning in this talk because this approach is completely different from the previous one. What this is actually doing now is to make a computation only client-side, no backend involved. This means that this extension uses the MPL exporter, which means that the Python code get the data, get the attributes from Matplotlib objects, translate it in JavaScript objects, pass the data to the D3 rendering engine, and it is done. So it's all the computation is client-side, no backend involved. So the interaction is smoother, as you can see. For instance, I commented this, but just to be sure that I'm not a liar, you may see that the MPL D3 object fig2dict translate the figure, Matplotlib figure, in a dictionary of attributes that will be fed into D3 engine. The last example is to show you that MPL D3 can be extended by plugins. In this case, we may use a plugin to add the label to every point we have. And the last one, the linked brushing plugin that allows to select a single color in the brush in multiple figures. For instance, let's see how it works. I swear that is the last one example. So I select a single color, and this is replicated in every chart in this multiple charts. And that's it. Just do the last slide for the thank you for your kind attention.
Thank you, Valerio. We have some time for a couple of questions, so okay.
So first of all, thanks for your talk. Can you switch back to the notebook?
Yeah, sure.
Yeah.
Here we go.
Before you move to D3, and you have the sliders, what backend is that using? Is it still Matplotlib, or is it something different?
No, actually, okay, we may check it. First of all, we may do this. Okay, insert cell. We may call Matplotlib. No, Matplotlib.get backend. It's not imported, so I'm sorry. Import Matplotlib. Okay. Insert the cell above and Matplotlib.get backend. This is the backend used is the iPython kernel. So actually, this stuff works only in the iPython notebook, I guess, because, or at least you have to use this backend. And this is the backend that is called by the interact widget. So the interact widget feed the data to this backend, and then get the data back to render the new object, new Matplotlib object.
Yeah. I wanted to add one thing to this, is that you can change the backend of Matplotlib. For example, in my case, I use this I used a PNG backend, so that every time that I had a picture, I was saying a .png image. But you can also put it inside the graphical user interface. So if you put WX, it uses WX widgets as a backend, and you have a window.
Yeah, yeah, exactly. Yeah, this is exactly what I told, what I mentioned, what I'm referring when I told about the 6 graphical user interface toolkit that Matplotlib integrates to. So one of these is Qt, for instance, that you didn't mention. Qt is another one, very useful, I guess.
So any more questions? Okay, so let's thank
you,
Valerio.
Thanks a lot.